An irregular shaped object has a mass of 66.12 grams. When it is placed in a graduated cylinder containing 12.5 milliliters of water, the water level rises to 22.7 milliliters. Calculate the density of this object. So you're given mass 66.12 grams. This is your mass. Then you're also given a volume, and it's told that there's 12.5 milliliters in this graduated cylinder. So let's say it's like this, and you have 12.5 milliliters at first. So that's your first volume. Then you place that metal into the water, and it rises to 22.7 milliliters. So that's your volume 2. You want to calculate the density, which is mass over volume. However, you're given 2 volumes. Now, we don't care about the volume to start. We don't care about those 12.5 milliliters. That was just taking that volume and putting it into the graduated cylinder. I want the volume of the object. Taking that object and placing it into that graduated cylinder, and how the graduated cylinder rose to 22.7 milliliters. The difference in volume will give you the volume of your object. So volume of object is equal to the final volume minus the first volume. So you would take your 22.7 minus your 12.5, and you will get 10.2 milliliters. Now you have everything that you need to solve for your density. 66.12 grams divided by 10.2 milliliters, and that equals to 6.48 grams per milliliter. You want your lowest is 3 sig figs, which you're in, and then you're finished with that. The specific heat of tungsten is 0.032 calories per gram degree Celsius. If 0.448 kilojoules of heat are added to a 15-gram piece of tungsten that is initially at 19 degrees Celsius, calculate the final temperature of the piece of tungsten. Okay, so immediately we're talking about heat, there's mass and temperature. I know that I will have to use the heat equation. But first, wanting to break up everything that I'm given. So given here, 0.032 calories per gram Celsius. This is my, if I put it in another color, specific heat. Then I'm given 0.448 kilojoules. This is my heat, Q. Then we have 15.0 grams, 19 degrees Celsius. So we are told that we have the mass of 15 grams and initially 19 degrees Celsius, so T initial. And you want to calculate the final temperature. So you want T final. So I know my heat equation. I know that Q is equal to mass times specific heat and change in temperature. That triangle means change. So I can expand that and say Q is equal to mass times specific heat times the final temperature and initial temperature difference. We need to solve for final temperature. Before doing that, you have to make sure that all of your units are accurate. Because you want temperature, you want degrees Celsius. So looking at all of these, everything but degrees Celsius has to cancel. So you see that kilojoules and calories are not the same. So you take one of those numbers, it does not matter which one, and convert to match those units. So you could say, all right, I'm just going to do my kilojoules, convert this to calories, but you can also convert the specific heat to kilojoules per gram degree Celsius. So I convert heat from kilojoules to calories. So I take the 0.448 kilojoules times, now I have to remember the K prefix. This is bigger. 1,000 joules is in 1 kilojoule. So times 1,000 divided by 1 kilojoule times my conversion to calories. So 1 calorie is equal to 4.184 joules. And that equals to 0.448 times 1,000 divided by 4.184 is 107.075 calories. This is not the answer that I want, so I don't have to worry about significant figures. Now we can solve for the temperature. Just plugging in values. So I have, if I write my equation back up here, I have my heat, which I converted, 107.075 calories, is equal to the mass, 15 grams, times the specific heat, 0.032 calories over grams Celsius. Final temperature, I don't know, and initial temperature is 19 degrees Celsius. So then you can just multiply one at a time. If you multiply these two together, your grams cancel out, and you would get 0.48 calories per degree Celsius. Then you would divide over the 0.48 on both sides, which will be 223.07. Now your calories cancel, you're left with Celsius. And the last thing is you add the 19 on both sides, and you would get that T final is equal to 242.07 degrees Celsius. Now you go back and check significant figures. You have 2 here, 3, 2, 3. So you want your answer in 2. So that would be 240 degrees Celsius. And then you're done.